Hey, space cadets and physics fanatics, ever heard of John Bell? Probably not. And that's kind of the point. This video is about a celebrity, but not one you'd recognize. We're talking about a quantum celebrity, a physics hero whose name might not be etched in stone, but whose work changed the very fabric of our reality. This is the story of John Bell, the genius from Northern Ireland, who took on Einstein and won. No, really, he bested the big guy himself. If that doesn't scream celebrity status, then I don't know what does. Now, before we delve into the quantum conundrum that made Bell famous in certain circles, let's get the obvious out of the way. Yeah, he wasn't a household name. He didn't grace the silver screen or headline music charts. Our John Bell was a physicist, a man of numbers, theories, and equations. But to those who understood his work, he was a legend. Think of him as the Brian May of physics, if you will. May, the lead guitarist of Queen, also had a PhD in astrophysics. But he chose music over cosmology. And Bell, well, he chose physics over fame. Both men used their extraordinary talents to change the world in their own right. And that, my friends, is the stuff of which celebrities are made. But how did Bell become such a big fish in the small pond of theoretical physics? Well, his story begins in the early days of quantum mechanics, when the big daddy of physics himself, Albert Einstein, along with Boris Podolsky and Nathan Rosen, wrote a paper that shook the foundations of the field. The paper became known as EPR, like the initials of the authors, and dealt with the issue of quantum entanglement. For those quantum-challenged folks, don't worry, I'll fill you in. Entanglement is a phenomenon in which two particles become linked together in such a way that they share the same fate, no matter how far apart they are. Einstein, along with most physicists at the time, found this idea preposterous. They called it spooky action at a distance. The thought that a particle here could influence its entangled partner instantaneously on the other side of the universe seemed to violate the very essence of reality as they understood it. To Einstein, this concept was unscientific and downright scary. But here's the kicker. This is where our boy Bell enters the stage. Unlike Einstein, Bell didn't dismiss quantum entanglement as spooky or nonsensical. Instead, he embraced the weirdness, accepting it as a fundamental aspect of the universe. But that's not all. Bell went further. He took the perceived flaws of quantum entanglement and turned them into a strength, a foundation upon which he built his own theory. And this wasn't just any theory. It was a groundbreaking work that provided a way to test the predictions of quantum mechanics against those of classical physics. The result, Bell's theorem, a set of equations that have had a profound impact on our understanding of the universe. This theorem has been called the most important contribution to the foundations of quantum mechanics since the work of Schrödinger and Heisenberg. And you know what? They're not kidding around. Bell's theorem has been the cornerstone for many of the advances in quantum physics, allowing scientists to better understand the nature of reality. So now you can see why Bell is a celebrity among physicists. He took something that was considered bizarre and incomprehensible and wove it into the very fabric of a new reality. And this is only the beginning of the story, because Bell's work didn't just change the course of physics, it also changed the course of our understanding of the universe. But you're probably wondering, okay, what exactly is this Bell's theorem, and why should I care? Well, I'm glad you asked. Let me explain. Imagine you have two entangled particles, like two coins that are magically linked. When you flip one coin and it lands on heads, you instantly know the other coin will land on heads too, no matter how far away it is. But in the quantum world, things are a little different. These entangled particles are like coins that have a 50-50 chance of landing on either heads or tails. But here's the twist. Before you actually flip the coin, it's in a state of limbo, existing in a quantum realm where it's both heads and tails at the same time. Only when you measure it do you get a definite result. That's the spooky part. The act of measuring, of observing the quantum world, actually influences the outcome. It's as if the coin knew you were watching it and decided to land on heads just to impress you. And that's where Bell's theorem comes in. It provides a way to quantify this inherent randomness, giving us a mathematical framework to understand the probabilities involved in these quantum shenanigans. In essence, Bell's theorem tells us that quantum mechanics isn't just a bunch of spooky, unscientific mumbo-jumbo. It's a real, quantifiable phenomenon that's as predictable as the flip of a coin, just with some seriously mind-bending twists. All right, so we've established that Bell's theorem is a big deal. But why does it matter? Why should you, a humble viewer of YouTube videos, care about this seemingly esoteric bit of physics? Well, because Bell's theorem is more than just a mathematical curiosity. It's a gateway to understanding the true nature of reality. It's a key that unlocks the secrets of the quantum world, revealing a universe that's much weirder and more wonderful than we ever imagined. And here's why. The implications of Bell's theorem go far beyond the realm of theoretical physics. It has practical applications that are changing the world as we know it. For instance, quantum entanglement, the phenomenon that Bell's theorem helps us understand, is now being harnessed to do everything from creating ultra-secure encryption to developing powerful new computers. That's right, quantum computers that can perform calculations exponentially faster than traditional computers. It's like having a personal assistant who can do your homework for you. Except this assistant lives inside a quantum realm, where the laws of logic are turned upside down. And Bell's theorem is the guide that helps us navigate this strange new world. It's the roadmap to harnessing the incredible power of quantum mechanics. Now, you might be thinking, quantum computers, encryption, who needs that? But trust me, we all do. These technologies aren't just the stuff of science fiction. They're already here and they're poised to revolutionize our world. Secure encryption will protect our data from hackers. Quantum sensors will detect things with unprecedented accuracy. And quantum teleportation, yes, that's a thing, will allow us to communicate instantly across vast distances. All of this is made possible by a deeper understanding of the quantum world, a world that Bell's theorem helped us unlock. So the next time you hear someone dismiss quantum physics as some kooky, unscientific mumbo-jumbo, tell them about Bell's theorem. Tell them about the celebrity physicist who showed us that the universe is much weirder and more wonderful than we ever dreamed possible. Tell them about John Bell, the man who took on Einstein and won, the man who unlocked the secrets of the quantum world and changed the course of history. And with that, we come to the end of our tale of John Bell, the quantum celebrity. Now, I know you're dying to know more about quantum physics. You want to dive deeper into the weird and wonderful world that Bell helped us understand?